Here's the last circuit of this lab, which is the RLC circuit, the high pass filter. So it's capacitor, resistor and inductor, and the output is across the inductor. So for the inductor, the only option we have in the lab is the 2.7 millihenry. And for the capacitor, I chose the capacitance values, the 1.5 nanofarad, the 10 nanofarad, and the 68 nanofarad. The 1.5 is to give me the underdamped response, the 10 nanofarad to give me the critically damped response, the 68 nanofarad to give me the overdamped response. And for R, I'll choose the one that is critical for C2. So it's 1 kilo ohm. So the 2.7 millihenry and the 1 kilo ohm, and I'll start with the underdamped component, which is the 1.5. So here's the input from the function generator. It's connected to the capacitor, the 1.5, and then in series with the 1K, and then in series with the 2.7 millihenry inductor, and then to the ground. The output is across the inductor. Here's the output. And to set up the function generator, the amplitude of the square wave is 2 peak to peak, and the frequency is the resonant frequency of this circuit divided by 12. So the resonant frequency of the first circuit with the 1.5 nanofarad is 1 divided by 2 pi square root of LC, and this gives me 79.1 kilohertz, and this divided by 12 gives me 6.59 kilohertz. So let's set up the function generator. So it's a square wave. Amplitude is 2 peak to peak. The frequency is 6.59 kilohertz. So here's the response, and it matches the yellow waveform here. So the yellow waveform gives me the transient response of the underdamped circuit. Now let's check the frequency response of this circuit. So it should give us the maximum value or the maximum output value around the resonant frequency, which is the 79. It should decay, or peak to peak 2 should decay to the input voltage below the resonant frequency, which is 2 peak to peak, and it should decay to 0 above the resonant frequency. Let's check this on the function generator and the oscilloscope. And the function generator, let's start with the 100 hertz, or let's start with the resonant frequency, the 79.1 kilohertz. So we can see the peak to peak 2 is around 5. If I go above the resonant frequency, peak to peak 2 decays decay to 0. Let's go back. This is the maximum at the resonant frequency. Below the resonant frequency, it should decay to the input voltage, and the input voltage is 2 peak to peak. Okay, now let's move to the critically damped circuit. All I need is just to replace the 1.5 capacitor with the 10 nanofarad. Since I'm using different capacitor, there will be a different resonant frequency. So for the 10 nanofarads and the 2.7 millihenry, I have the 30.6 kilohertz And to set up the function generator, I need to divide this by 12. So I'll set up the function generator to 2.55 kilohertz. Here is the response. It matches the red waveform here. So it's the same as the previous waveform, but it's narrower than the previous one. The red waveform. I mean the purple one, the critically damped. And for the frequency response, at 100 ohm, at the 100 hertz, the voltage should start from 0, and then it should be increasing, and above the resonant frequency it reaches the input voltage. So let's do this here. While I am increasing the frequency, peak to peak 2 increases. And the resonant frequency is 30.6. Sure why this goes to a maximum value and then decays. To the input voltage. Anyway, it should give us exactly as this. Let's cut this. I will not do this part. Just let's stick to the first part. Okay? This is wrong. This doesn't matter. Let me go to the third circuit, just for the transient response. Now for the third circuit, the overdamped circuit, I'll replace the 10 nanofarad with the 68 nanofarad. And the frequency, the resonant frequency is 11.7 kilohertz. And 11.7 divided by 12 gives me 978.8 hertz. So let's set up the function generator for the frequency, hertz, and autoscale. And this is the transient response for the overdamp. And this matches the red waveform here. Very narrow. And for the frequency response, it's the same as the critically damped, but critically damped and overdamped starts at 0 below resonance and increase to the input voltage, but the overdamped circuit increases more slowly.